Hello, let's continue our Sudoku adventure with Ridiculously Chaotic by Randall, with chaotic. Do we pronounce that Xhaotic? I'm not sure. Or Xhaotic. Anyway, this continues our celebration of hitting Sudoku Adventure 1000. I'm going to read Randall's inspiration here. So it's inspired by the Sudoku Adventure Chaos Construction Theme Week, 611 through 617. Most especially GDC's 4 ridiculous facts about chaos, which is utterly perfect in its simplicity, while still being approachable and very fun. And Strosahl's Xhaos, because I'm a sucker for Exums puzzles. All right, so it looks like it is an Exum related chaos construction. Let's go over the rules, especially what the heck is chaos construction? Well, so you'll notice we don't have any bold borders in this grid right now. So we are still doing every row and every column. We are placing the digits 1 to 6 exactly once each. So it's a Latin square. But there are regions in this grid, but it's up to us to discover where they are. So for example, we might have a region like this. We'll call that the green region. Then we might have a region like this. We call that the purple region. So there's going to be 6 of them in the grid, each with 6 cells. And digits also don't repeat in those. But we don't know where they are. We know that they exist, and they follow certain rules that we're going to have. But we don't know where they are from the start. So part of the puzzle is discovering where those regions are. All right, so let's go over the other rules we have. We have these digits outside the grid, the 5, the 10, the 13. These are X-sums. So they indicate the sum of the first n digits, where n is the digit closest to this clue cell. So let's say this was a 3. This is our n. So that's telling us that these 3 digits, including itself, sum to 10. So we already have 3. These would sum to 7, so we could just say 2, 5. So you notice 3 plus 2 plus 5 is 10. That matches our 10. But if this was a 4, we might have something like this. And you notice 4 plus 1 plus 2 plus 3 sums to 10. So this tells us how many digits we're going to be using. All right. In addition to that, so let's put this back. In addition to that, every row or column with the clue, the first n cells are in the same region as each other. So these would all be in the same region. And then the n plus 1th cell, the next one, is a different region. So I recommend using just black region borders using the pen tool. If you don't have the pen tool, you just go into the settings. It's the very, very first setting to enable the pen tool. All right. So that is how that works. We also have Exum circles. So let's clear this out. Oops. Let's clear this out. A digit in a circle counts how many cells of its region it sees in its row and column combined, including itself. So let's say we had a region like this. So how many, and then, so of course, then there'd be a border around it, right? So how many cells does this see? Well, it sees itself. It sees these 2 in the column and this in the row. Region borders obstruct vision. And so that's 4. So we'd put a 4 here. And then these would all add to 10, which is the sum given here. So we do say 1, 2, 3 like that. So 1 plus 2 plus 3 plus 4 is 10. So that would be one way to fulfill this X-sum circle. All right, now these 2 circles do not give the sum, so they're just the count. But these 2 do give the sum, so they're the count goes in it, and then the sum is given. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. Let's start with this 5 here. Actually, the first thing I'm going to do is I'm going to bold the outside of this. We know those are region borders. All right. So 5, how are we summing to 5? Well, we can't put a 1 here because 1 includes only itself and would sum to 1. So you can't put a 1 there. Now a 2 would put a 3 here, 2 plus 3. That would be perfectly fine. A 3 doesn't work though, because the very minimum that I could do is 3 plus 1 plus 2, which is 6, and that overshoots our mark. And so the answer is this is a 2 and this is a 3. And then they are in the same region. Let's just start with the green region here. And then we also know that there's a border here, and we're going to start a new region. We'll call it the purple region. All right, now this 13, it seems to meld into the 13, or maybe this 21. 21 is the sum of the entire region. 1 through 6 sums to 21. So this has to be a 6, first of all, and it has to see all the cells in its region, which means that the region has to be fully in its row or column which means that it cannot be green, because if it was green, we wouldn't see the 2, and that's no good. So let's call this orange, and we'll put a border here. Now, it can't be purple. And normally I'd be like, hey, we don't know if it's purple or not, but it can't be because it doesn't see purple. This sees its entire region. And so now green needs to be 6 in size, and so we need to grow here, and then we still need to grow, so we need to grow here. So we have a border here. All right, now orange is going to grow some amount this way and some amount this way. Even if it took the entire row, it would only have 5 cells in it. So it needs to also take at least 1 from the column. And similarly, even if it took the whole column, it would only have 5 cells in it. So it needs to take this in the row as well. And so now we know there's a border here. Again, I already explained why orange isn't purple. And so purple needs to grow. All right. Now what do we do from here? We could look at the 13 or the 10. I'm kind of interested in the 13 a little bit here. So again, can't be 1. 2 is way too small. 3, the biggest we could do is 3, 5, 6, which, what does 3, 5, 6 add to? It adds to 14. So 3 is possible. 3, 4, 6 would do it. That makes sense. So we could be a 3. We could be 4. Now 5 is not possible because 5 cells add to a minimum of 15. 1 through 5 is 15. So this is 3 or 4, meaning we don't quite make it to here. Now we know that, sorry, I should draw these borders. We know that orange is going to take some number of the column and some number of the row, but nothing else. And so we already have this border here. So it makes sense for this to be a 4. If it was a 3, we take these 3 and then there would be a border and this would be a new region, which is also possible. Let's see. Let's think about the 10 then. Because 2 and 3 are gone. So it has to be 4. Again, 1's not possible. 4. And then this is going to be a 1, 2, 3. And then these are on the same region as each other. It could be purple. We know there's a region border here. These are from 1, 5, 6. Oh, no, sorry. I was thinking something wrong. If it was purple, it would make perfect sense. And then this would be a different region, because it would be a 1. Purple would finish the region. I'm not sure. One thing we do know is it's not orange. That's important. This is not orange, because it's a region that like this, and 6 needs to see it. Again, orange is only in this row and only in this column. I don't think I need to explain that again. But so that would mean that this can't be orange, because it's part of this region. These are together. So as a result, orange can only take these 3, which means it needs to take at least 3 more. So these are all orange. And again, orange has to do that. And so green's gonna continue till it's done. This is green and it's over. Okay. And so now this cell here is some new region. We'll call it yellow. Yellow has to grow, and we know that orange can't do that. And so orange actually grows here. Whoa, sorry, I'm in the wrong mode. Sorry. Okay, orange grows here, and now orange is done. That is 6 cells. All right, now yellow has to keep going. So this is our yellow region. And now we know that yellow goes up at least 3. So this is also the yellow region. 1, 2, 3, 4, 5. So it either continues to here or continues to here. Or I don't know, I guess it could continue here or here as well. I don't think it can take this one, though, because if this was yellow, 1, 2, 3, 4, 5, 6, we'd be done, and we'd only see 2 cells, and 2 cells would have to add to 10, which we can't do with a 2 in here, right? If this would be a 2, because this region's done. So this would have to be an 8. That's no good. And so we are not taking this one, meaning this is a border. Let's see. I mean, I'm thinking this is purple. This is a region, and then like this is a region or something like that, but we'll see. I think we can't just like guess. We have to prove it. Is there any like Sudoku I can do at this point? We know some regions. So this 3 has to go somewhere in this column. So it actually ends up here, and that's actually really important because that makes this a 4. So that means that's yellow, and now yellow is done. And so now this 10, If the 10 took this one, it would have to inherit all of these. Oh, so sorry. There's a really obvious thing we can do at this point. I think we didn't know that until orange grew. So I'll forgive myself for that. But these have to be purple because purple has to escape. And now that this 4 is purple, these are all purple. So it does what I thought it was going to do, which is that. And so now this has to be a new region, and it has to grow at least to here. What's next? The red is next, I guess. I think I skipped red earlier. All right. So this adds to 10. So it's a 3 or a 4. It can't be any bigger than that, no matter what. And this has to be a region, so it's going to grow all the way down to here, and that's the blue region. And that's a circle. It's at least 5. Oh no, it's going to be 6. Because it sees all 5 of these. And then we can only grow one more to either here or here. So this is definitely going to be a 6. That means that's not a 6. Oh, sorry. We know this is a 1 because the 1, 2, 3 took 1 out of these. Anyway, forgot about that logic. Now this we actually know is a 5. It just sees 5. Let's see. What else do we have? So this is going to grow here or here. And then be done. So red has to take these two. We don't know which one red takes yet, but we know that this is a 4 now. And we know that this is a 1, 2, 3 triple. That's not a 3. So the 5 goes here in order for it to add to 10, in case that was not clear. Makes that a 6 and a 5. I think we just got to do some Sudoku here. Where do we want to do it is the question. 5 in this column can only go here because it can't repeat in the orange. So this is a 1, 2, 6. That's not a 6, which makes this a 3. Right, 3 had to go in this column somewhere. That's not a 3. Oh yeah, we have 1, 2, 3, 4. So this is 5, 6. So this has to be the 5 and this has to be the 6. I don't know what blue is missing that it has to take, or if it just takes the whole column. So I guess one argument we could make is that we can take, red can take this and then blue can take this and everything will work out just fine. So that's going to be what happens. Otherwise there's ambiguity, but we haven't quite, we want to prove it in a more direct way, not through uniqueness. All right, 1, 2, 4 go here. We can clean it up a little bit. What else can we do? This is 1, 2, 4 as well. This is 1 or 4 only. And so what's this one? Oh yeah, this is where the 6 goes in green. This is where 6 goes in yellow, or the column. So this is 2, 3 only. It's not a 1. 1, 2, 3 triple makes this a 4. And now this is where 5 goes. And so now blue can't take the 5. And so it does exactly what I said. And I do believe that the regions ended up exactly how I visualized earlier, early in the puzzle. But that's fine. That's kind of what I expected. So this is 2. This is 1. This is the 3 and the 4. This is the 1 and the 4. This is 2, 1, and 3. This is 2 and 3, 1 and 2, 1 and 2. And we're suddenly done. All right. Really nice puzzle, Randall. I know how difficult chaos constructions can be to make because I've made one and it was hard. And so I'm glad that you were inspired to make this. This was really fun. Cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.